Are you tired of hearing the server is down at the worst possible moment, wondering what really goes on behind the scenes of the internet, your emails, and even your company's shared files? In this video, we'll reveal the essential role of servers from file sharing to email management and why understanding them is crucial for any IT professional. Stay tuned, because by the end of this video, you'll know how to leverage servers to boost efficiency, security, and connectivity. Don't miss it. In this course, we're going to talk about computer servers. Expressions like, the server becomes unresponsive, or the server is inaccessible are certainly familiar to you. Whether you are technicians, entrepreneurs, or corporate executives, you need to know that you are manipulating your data thanks to the servers. So, what is a server? Well, it's very simple. It's the supercomputer with technology that provides you with all the data you need and all that, 24/7. For example, if you want to send an email or access a database, well, it will be a server, which will provide you with these different services. You should know that the server will give you the information or data only if you ask it. That is, it is your requests that allow the servers to satisfy you. And this is where the concept of the client-server relationship comes in. That is, the client issues a request so that the server can provide the services. Now that you understand the principle, let's see what it looks like. Physically, the server looks like a drawer that is inserted into a large cabinet, also known as a computer rack. Inside these servers, well, I'd say there's nothing rocket science, because you will find the same components as a simple computer. Now that the basics are laid on the servers, we're going to look at the different types of servers as well as their roles. The web server allows the storage and provision of web pages on the internet or the intranet. In order for these pages to display correctly, a programming language must be used. And one of the main languages used by web servers is HTML. The web server also uses different communication protocols to be able to send you the page you request. The web server can be either service software or a computer server. In some cases, the two can be combined. Generally, the web server is connected directly to the internet to be able to host resources such as web pages, images, video, etc. These resources can be either static or dynamic. In a static resource, web pages are served as is, and in a dynamic resource, they are built on demand by the server. The file server allows files to be shared between staff within the same company. To go more in detail into how it works, we have a mainframe, which is configured to act as a server, and several PCs that play the role of clients. The file server is a bit of a backbone of the company because all the computers connect to it to retrieve the files shared together. The print server simply allows you to share one or more printers between several users on the same network. In fact, the print server allows a printer to connect to a local network rather than a single computer. This avoids having a desktop printer for each employee of a company. Now, let's talk about the DNS, Domain Name System Server. The main function of the domain name system is to translate a domain name, such as formip.com, into an IP address, such as 92.145.0.8. To understand the role of a DNS server, we can take the example of the telephone. What do you do when you want to call someone when you don't know their phone number? Well, you use a telephone directory, which allows you to make the relationship between the name of your interlocutor and his or her phone number. Well, the DNS server is the same. This is a directory for computers. The DNS server therefore makes it possible to make the relationship between the name of the computer and its IP address. To fully understand how it works, let's take an example that will combine both a DNS server and a web server. Let's say you want to go to the formip.com site. To start your computer, go ask the DNS server, "What is the address of www.formip.com?" Then the DNS server will answer you that it is the IP address 188.165.51.93. Your computer will then be able to send an HTTP request to the formip.com web server through the IP 188.165.51.93. And finally, the web server will send the home page to your computer. The DNS server is only used to translate domain names into addresses. That is, if instead of www.formip.com, you write http:// plus the IP address, then you should also see the Formip homepage. It is important to know that DNS servers work in cascade. That is to say, that if a DNS server does not know the IP address of a server name, well, it will ask its parent. For example, in your home, the DNS server is your internet box. If your router does not know how to answer, then it will query its parent, which is none other than the DNS of your internet service provider. That when you configure your computer's DNS, it is provided by the DHCP server, and precisely, it's the next server we're going to talk about. DHCP, Dynamic Host Configuration Protocol, is used to automatically distribute IP, Internet Protocol, addresses to the various devices on a network. DHCP is therefore a network protocol which avoids the user connecting for the first time, having to configure these IP settings. As you can see, this protocol greatly facilitates the job of the network technician. The proxy server is a kind of bridge between the internet and you. It allows users to be separated from the websites they visit. This ensures a high level of security and confidentiality. In fact, if you use a proxy server, then the internet traffic will first go through that server before going to the website you are requesting. And it's the same for the reverse path. That is, the web server's response will first go through the proxy before reaching you. As you can see, having a good proxy allows you to protect yourself from external threats from the internet. Let's move on to the mail server, which is nothing more than an email server. The role of the mail server is to receive and send emails. To do this, the mail server will use three very specific protocols: Simple Mail Transfer Protocol, SMTP, the POP Post Office Protocol, and the Internet Message Access Protocol, IMAP. The first protocol, SMTP, takes care of sending your message, while the other two, POP and IMAP, are responsible for receiving your message. The authentication server makes it much easier to authenticate a user or a server that tries to access a network. Authentication is the process of confirming the identity of the person or device before logging in. The authentication method may very well be a login-to-password pair, such as biometric verification. Among the main authentication protocols are Radius, remote authentication, Dial-in user service, which is a protocol that operates on a client-server model. We have the CHAP, Challenge Handshake Authentication Protocol, which allows you to connect very securely to a system. And we have the Secure ID Protocol, which allows us to identify all users of the system and the network at once. The syslog server allows you to send system log files or events to a dedicated server, which is called a syslog server. Logs are categorized by different severity levels, which range from 0 to 7. In first, we have the emergency messages, which indicate that the system is HS. Secondly, the alert messages, which require immediate intervention. Then there are the critical messages, which inform of a critical error on the system. Then there are the warning messages, which inform you that an error can happen if no action is taken. In 5, we have the event messages. These are reporting notifications. In 6, the information messages. That is, they are just logs to inform the state of the system. And in 7, the debugging state, which lists all the actions taken by the system. Before we end the course, we're going to talk about Internet appliances. It is simply a device which is able to easily access Internet services. In fact, it can be seen as a server, except that the device will be specialized mainly on a single specific task. UTM, Unified Threat Management. UTM is an example of an Internet appliance. The initials UTM stand for Unified Threat Management. You guessed it, it's an all-in-one security solution. That is, it is a device capable of providing multiple security functions at a single point on the network. A UTM appliance therefore makes it possible to combine several security functions, such as antivirus software, anti-spyware software, anti-spam protection, and a firewall, but it is also capable of providing intrusion prevention and detection, and it also has filtering on different content, such as the internet, for example. Basically, it also acts as a proxy. It is therefore an all-in-one solution, which avoids having to use several suppliers to manage these different services. Another advantage of having a system that centralizes several departments is that it reduces administration to a single segment. That is, network administrators will connect to a centralized console to manage multiple services. IDS, Intrusion Detection System. Let's move on to another appliance, which is the IDS. It is a system for detecting intrusions. The device will receive a copy of all network traffic so that it can then analyze it and see if there is any malicious code. It should be noted that the IDS is an offline device. That is, it will only be able to detect malicious traffic or any kind of intrusion activity. Since it is offline, it will be unable to stop this type of traffic. IPS, Intrusion Prevention System. Whereas IPS is a device that aligns itself with network traffic and can analyze it in real time. It is therefore able to stop malicious code. And to end this course, we're going to talk about legacy system, which is actually an obsolete computing device, but still in use. That is to say that this type of technology does not allow it to be compatible with other devices. Let's say that it's a piece of equipment that doesn't progress, and that only does what it was intended for. So, we could ask ourselves the question, what's the point keeping this type of device? Who is not able to keep up with the rapid evolution of the IT world? Well, actually, there are several reasons. It may be because of an investment problem. Even if the maintenance of an old system can be very expensive, well, its replacement may require a hell of an investment. It can also be because of the fear of changing the system. If the device is used by many employees, well, there may be some risk in replacing it. And the last reason is the difficulty of migrating to another system, because it is very likely, given its age, that the programming language is also obsolete. This may make it difficult to find someone with the right skills. And finally, the embedded system is a combination of computer hardware and software, which have been designed for a very specific function. As an example of an embedded system, we have automobiles, mobile phones, industrial machinery, but also medical equipment,